Hello everyone, welcome back to This Is Not a Science channel, and today for our physics video we will start a brand new topic which is about motion. And motion is one of the fundamental parts of classic physics, where it involves speed, velocity, distance and time. So it is very important for us to look into motion in very detail. So let's start. Usually when we talk about motion, the word motion derives from the word movement. So movement basically means when an object is not stationary. So when an object is moving, we call that object having a motion there. So when we talk about motion, the first thing that comes in our mind should be something like speed. So how do we define speed? Well, most of the people will believe that speed is basically how fast something is going. Well, that's not wrong, but there is actually a way to properly define speed using a physics formula. And I'm pretty sure most of the people would have learned this in their primary education or have seen it somewhere else, because it's very useful in our daily life. A lot of things around us involve speed, so we need to know how to calculate speed. Therefore, we have this formula right here. Speed, usually the standard unit is in meters per second. Speed will equal to distance with the unit meters over time with the unit of seconds. So distance divided by time, we get speed with the unit of meters per second. This formula is absolutely essential for human being, because in our daily lives we encounter speed so many times and we need to know how to calculate them. Well, looking from the formula, we can actually try and understand what speed actually is. Well, distance divided by time, basically speed is distance per time. So in other words, we can phrase it as how many distance did you make in a given amount of time. So how many distance did you travel per second? So let's try this warm-up question where we actually put this equation into practice. So I bet everyone knows Usain Bolt. He's the fastest runner on earth. So they said Usain Bolt holds the record of completing the 100-meter race with the shortest amount of time in just 9.97 seconds. So can you calculate his speed during the race? So pause the video right now. A nice little warm-up question just for you to get familiar with the speed formula. So pause the video right now. I'll check back later. Okay, I hope you guys found that really straightforward. It's just simple division work. So we got 100 meters and our second is 9.97 seconds. So in this case, we can list out the formula. Speed equals distance divided by time. In this case, it will be 100 divided by 9.97, which will take us into 10.03 meters per second. So that will be his speed during a race. And what does that actually mean? It means that Usain Bolt is capable of running 10.03 meters every second. That's what speed actually means. Once we're familiar with the speed formula, we have to take a look at a type of graph, and I call this distance time graph. And what does distance time graph actually means? Well, on the graph, it clearly displays two sets of axes. So we have distance and we have time. So distance is on the y-axis while time is on the x-axis. And this graph is absolutely essential because we can tell a lot of things using this graph. So let's take a look at what can we actually find on this graph. Clearly we see distance and time, but how do we actually use this graph, or how do we actually read it? Well, from this graph we can find three things. We can find distance, time, and its speed. So just imagine this object is moving, and from here, from the graph, we can tell that it traveled from 0 meters to all the way to 40 meters. So that's one thing we know. We know the distance. So we know this object has traveled 40 meters in total. And then we can know the time from here. From the x-axis, we can see that this object has spent a total of 40 seconds traveling. in this case, we can use the formula to find the speed. In this case, it would be speed equals distance divided by time. So we know the distance is 40 meters. And we know the time spent on traveling is 40 seconds. So 40 meters divided by 40 seconds, we get exactly 1 meters per second. And that will be the speed of the object. And we can simply tell that from looking at this speed time graph. Now it is important for you guys to actually put this into practice. So here we got a slightly different one. This is also a distance time graph, but it's slightly different, not like the previous one when it's just a straight line through. So we got 3 mini questions right here, and I would like you guys to answer it to see if you can work out an answer for every single one of these questions. It will be slightly challenging because this graph is not a typical speed time graph. So let's just pause the video right now and work out the answer. Now it is important for you guys to actually put this into practice. So here we got a slightly different one. This is also a distance time graph, but it's slightly different, not like the previous one when it's just a straight line through. So we got 3 mini questions right here, and I would like you guys to answer it to see if you can work out an answer for every single one of these questions. It will be slightly challenging because this graph is not a typical speed time graph. So let's just pause the video right now and work out the answer. I hope you had a good go on attempting these questions. Now let's take a look at the answers. So we have this. Question A, what is the difference between in speed between 0 to 10 seconds and 10 to 20 seconds? Well, we are asking difference in speed. So if we want to know the difference, we have to work out the speed first of all. So we need to work out the speed between 0 to 10 seconds, so this area right here, and we have to work out the speed between 10 and 20 seconds, so this one right here. In order to work out the speed, just like my previous example mentioned, we can work out the speed by calculating the total distance traveled divided by the total time spent. So between 0 and 10 seconds, it would be 10 meters because it traveled 10 meters based on the graph, and they spent 10 seconds traveling it, so 10 meters divided by 10 seconds, that will be 1 meters per second, and that will be the speed between 0 to 10. While as 10 to 20, it will be slightly different because clearly you can see the graph is now steeper. In this case, we can still calculate the speed by using the total distance traveled, but be careful, it's not 30. People might just read it from here and go like, oh, it's 30, but it's actually not. We have to subtract the speed, we have to subtract the distance right here. It actually only traveled 20 meters because 30 minus 10 is 20. So the total distance traveled from 10 to 20 seconds is indeed 20 meters. So 20 meters divided by 10 seconds, because that's a 10-second interval right here, we will get 2 meters per second. And 2 meters per second minus 1 meter per second, the difference will be 1 meters per second, and that will be the answer for question A. Finally, we got question C, and question C is asking you for the average speed of the whole journey. So the keyword here is average. So we're not just asking you for the speed, we're asking you for the average speed. So how do we actually calculate average speed? Well, you see this graph, sometimes they go in this speed, and sometimes they accelerate in a faster speed, sometimes they're stationary, sometimes they accelerate again and they're stationary. But in this case, we just want to know the average speed. So in order to calculate average speed, we need to know what is the total distance traveled and what is the total time spent on traveling. So from here we can tell, although it goes through this increase and sort of fluctuation, it eventually ended up around at 45 meters interval. So we can tell that this object has traveled a total distance of 45 meters. And how about the time? We can look at the x-axis. This object eventually stopped at 40 seconds. So we can tell that this object spent a total time of 40 seconds traveling. So it's pretty simple. To calculate average speed, just take the total distance traveled divided by the total time. So 45 meters divided by 40 seconds will give you an answer of 1.125 meters per second as the average speed. So that brings us to the end of the video. In physics will be a lot of doing questions and analyzing our answer because physics is all about doing it. It's actually working out how this will work in real life. Instead of comparing to biology, where it's more theory-based, physics will be a lot about actually applying the knowledge. So next episode, we will be talking about velocity and acceleration. We will be introducing slightly about vector values as well. And therefore, we will be talking about a different type of graph, different from distance time graph. We will be talking about speed time graph, and speed time graph is a lot different from distance time graph. So make sure, if you don't get this video, watch it over. Make sure you're very confident with the knowledge of distance time graph, because in the next episode we will be basing knowledge on this video to build on and learn about velocity or speed time graph. So make sure you like the video, subscribe to my channel, and share it to all your friends who hate science. I'll see you next time. Thank you very much.